All right, hello. My name's Sam. I'm going to do another Leetcode easy question today, so feel free to follow along. We'll choose one at random, and let's start the timer over here and see what we get. So we're doing question number 682, a baseball game, and you'll notice that I'm using a Google Doc here on the right. It's not because I prefer it over an IDE, it's because sometimes you have to use something like this in an interview. You don't get access to the autocomplete and the syntax highlighting. And the worst thing that happens is when you're in an interview and you're so used to using your IDE that you're just having a brain fart and you miss like a simple range, how range works in terms of the position of indices and things like that. This just kind of gets you used to the actual interview process a little bit more. And hopefully once you actually do work, you won't ever have to do it again. Let's see. Baseball game. You're keeping the scores for a baseball game with strange rules. At the beginning of the game, you start with an empty record. You're given a list of strings, operations, where operations by its ith operation you must apply to the record and is one of the following. An integer x record a new score, plus is record a new score that is the sum of the previous two scores, d, which is a double of the previous score, and c, which is remove the previous score. Okay, the c is the only one that is slightly interesting. Return the sum of all the scores on this record after applying all the operations. So we don't actually need to keep this whole record. We just need to return the sum of all the scores at the end. Okay, that's not too bad. This kind of reminds me of the other question we had that was Roman numerals, where you had special cases. I think this is kind of similar to that. The test cases are generated such that the answer in all intermediate calculations fit into a 32-bit integer. And that is the only other question I was really interested in, is whether we have to worry about integer overflow, or we need to use floats or anything like that. It looks like we don't have to worry about it. And so the strings will either be the integer or there'll be a special character. So we're kind of doing an iterative loop. I think we can just kind of approach one, iterate, apply rules. O of n for n steps. We can't really do better than that, I don't think, because we have to apply all the rules. And then O of 1, ideally we can do O of 1 space storing sum. So let's think our way through this. So let's call that thing, they call it calculate points. We have our operations. It'll be a list of strings, and our output is an int. And so for op in operations, we're going to check, let's take our total is equal to 0. So if op is equal to, can we ever have an invalid sequence operations? All operations are valid, yeah. So we don't have to worry about summing, like the first value being a plus sign instead of an integer. It'll always be an integer to start. So if the op is equal to plus, then we need to sum the last two values. So total equals total plus prev1 plus prev2. And we haven't created these yet, but we'll keep track of them in a minute. And then the next one is elif op is equal to d, then the total plus the prev1 times 2. Double, that is the double of the previous, no, of the previous score. Yeah, of the previous score, not the total sum. Okay, and then LFC total invalidates the previous score. So total minus the previous one. To invalidate. And that's how we can kind of deal with that. And then at the end, we just return our total. So now we just need to think about how we're going to get our previous one, previous two. So here we can just say prev1 is equal to, actually, we can keep our operations and say previous one is equal to operations of I minus 1 and here 5 to invalidate 5. Oh, that is the running total. 2 times 5. Okay, so this is wrong. And you should have looked at the example first. We're using the running total. Okay, so actually the record, let's call it the record. I think we do need to keep track of all of the values in the record. Let's just go along that way. And actually, what we'll do at the end is, otherwise it's the number, so the record append the int of the op, and that adds to the record, and this will become O of n for O of n space for record, storing all the values. We'll fix that later if we can help it. Actually, instead of minus, double last record. Okay. So this is a O of n and O of n. So this is the most brute force kind of way approach to do it. We, sorry about this spelling error right there. We are building up the record in real time and keeping all of it and then summing it up at the end. What I would like to do is only keep the last two values of the record and kind of like combine everything else if it ever gets longer. But we can't do that, actually, I just realized, because it's possible to remove the last like n records and then do a sum of the previous two before that. So actually, I think this is the best we can do. We are not allowed to throw away values in the record just because we might remove them at some point. Well, all right, let's see how this looks in here. We're about 7-8 minutes in. Glad we went with the brute approach, because I didn't. That is an interesting little insight to think about. You could be removing the last record multiple times in a row, and that would require you to keep track of all the record values, even from the very beginning of the array. So I don't think we can ever do better than O of n time and O of n space. Okay. Doubling the last value. Let's just make sure that's how double is supposed to work here. They say double a recording new score, that is a double of the previous. Oh, okay, so that's good to know. It's not replacing it. So glad we double checked the definition there. Record append record -1 times 2. Similarly, the sum is when you create a new record. That is the sum of the previous two. And then we invalidate by removing it from the record by pop. And pop is on the right, I believe. Yep. This is O of 1, this is O of 1, this is O of 1, O of 1. This is all for a list, O of n, O of n. Yeah, okay. I think this should be good. I'm trying to think of any edge cases I might be missing. We're always guaranteed to have legal operations. Okay, let's see what we get. And it passes the test cases. That's always a good sign. And finally, let's submit and see what happens. And it passed. All right, always good to see. We're kind of in the main ballpark. I'd be interested to see if there's any sort of optimizations that we could do under the hood here that aren't just kind of underlying C tricks. I'm not entirely sure there is. One might argue that you could do some sort of sequence of on the operations one time to check for all the potential integer values, and then you don't need to store everything, and you could sum it up as you go because you know the order of everything coming in. Can't see how to do that without that's any better than this per se. Let's have a quick look and see what we get when we're here. Yeah, we got our stack, append, push. They store in the stack as the value, int value. I don't know why they did int again here. That's kind of weird. Pop. Yeah, it's exactly the same. Okay, I think this is maybe the vagaries of how you run this on the back end. Somewhere between 20 plus or minus 20 milliseconds is within the range of error for how Leetcode runs its examples. Anyway, good to see. I hope this is interesting to you all, and see you guys next time.